everyone, this is a TinkerPlots demonstration of the Memorization Part 2 activity, which demonstrates how to compute a confidence interval for a difference in two means. So the first thing I'm going to do is plot the observed data because I want to calculate my observed difference in means. And this is done for you already in your book on page 325, but I'm going to do it here also. So first we're going to plot the JFK data and get the mean. You can ignore these two dots here. They're just there because the sample sizes are unequal, so there's two blanks, but don't worry about it. So the mean here is 16.76, and the mean for the JFKC data we'll find from this plot. And so the mean here is 9.47. So if we subtract this 16.76 minus 9.47, the observed difference is 7.29. So the observed difference in means that we found is 7.29, and we'll keep this in mind for later. But for now, we'll collapse these two plots. So we're going to set up two samplers, and the reason we need two samplers is because our sample sizes are uneven. One's 17, one's 19. So we need to empty these out. And we'll just draw one from each. So we need to copy and paste the attributes here. So this first one, highlight JFK, right-click and copy. We go to our mixer and paste cases. And we're going to label this JFK. And then set the repeat to the sample size, which is 17. And the replacement is with replacement, because we're assuming this is like a picture of the population, and so we're sampling with replacement. We're assuming that the population is many, many copies of this sample here. And the other one will do the same thing, but for the other group. Copy and paste. We call this JFKC. And we have 19. And again, we also want to do with replacement, and it's already selected by default. So we're going to run each sampler separately. And plot the means. And as you see, this screen's going to get kind of crowded, so you can start collapsing things. So we can plot the JFK group first. And get the mean. And then plot the JFKC group. And get the mean too. So now we're going to collect both means. I'm going to collapse more things to make some space. We'll collect that one as well. And we're going to run these separately. So we need to do 499 trials. And I'm going to collapse these plots so that we can turn off the animation. So we go to Object, Inspect Collection, uncheck the animation, and get 499 trials. And then same thing here, we have to turn off the animation for this one also. Object, Inspect Collection, and uncheck the animation. Okay, so now that we have 500 means for each of these groups, we're going to get the mean difference. So we make a new table and have an attribute called mean difference. And we're going to copy and paste each of these columns onto there so that we can get the mean difference. So we get the mean of JFK, right-click, copy attribute, and then click here on the mean difference, right-click, paste attributes. And then we also do this here. Copy the other group means, and then paste attribute. So you should have both. Let me expand this so you can see JFK and JFKC. You should have the 500 sets of means here, and then the new mean difference attribute you've created, and we're going to edit the formula so that it gets the difference. So to get the difference, we just subtract them. You can double click on JFK and then minus JFKC. Notice this is the order of subtraction we used with the original data. When we first subtracted the means, we did JFK first and then JFKC. So we want to be consistent here and do the same thing. So there's the mean difference. And we'll plot these 500 differences. We can get the average just to show that it's at 7.2, which makes sense because our observed difference was 7.29. It's pretty close. It's not going to be exactly at 7.29, but it's going to be pretty close just because that's the model we're using, is that our observed difference was 7.29. So then the next step is to get standard error. So I'm going to make a new attribute called standard error. And then right-click, edit formula, and use the stddev formula and put the mean differences in it, because we want to get the standard error of the differences, not of the original means. So we want to double click on mean difference here. So it's 2.07. So this standard error, that's what we're going to use to compute our interval. So I'll do this in a text box so that you can see it. So the interval is computed with the observed statistic first. We do not want to use this 7.21 because that's from our plot. We want to use the observed statistic that we had of the 7.29. And then plus or minus 2 times the standard error. So the standard error is about 2.08. So this would turn into 7.29 plus or minus 4.16 is our margin of error. And when you do this in your calculator, you should get 7.29. You do minus 4.16 first. You get 3.13. And then when you do the plus, you get 11.45. And so this is your confidence interval. So you can be 95% confident that the true difference in averages in number of letters memorized is between 3.13 and 11.45. So that's your confidence interval for the difference in mean number of letters memorized between the two groups.